Hi, this is pre-algebra lesson 3-4, and this time we're going to be dividing rational numbers. So dealing with fractions and decimals. But the first thing that I want you to notice is this word reciprocal. I made it plural with the S, but the main word is reciprocal. So I'm going to move you over to your book. We're on page 126. And reciprocals are an easy, neat concept. The reciprocal is the opposite or upside down version of a fraction. So if we have 3/4, the reciprocal of 3/4 is simply 4/3. If we have 5/12, which is negative in this case, the reciprocal of it is literally its upside down fraction, which is 12/5 and stays negative. If we have 6, you have to remember that every 6 is really a 6 over a 1, so its reciprocal is the upside down version, which is 1/6. Now let's talk about why that's important. That's important because we can multiply a number by its reciprocal and always get the answer 1. Let's look at why that happens. Because when we flip it upside down, we're then multiplying by things that should cancel. The 4 on top would cancel with the 4 on bottom, the 3 on top would cancel with the 3 on bottom, and that equals 1. Or we could look at it this way, 3 times 4 is 12, but 4 times 3 is also 12, so 12 divided by 12 is 1. Or, actually I think those are the best ways to look at it. So now let's look at the next one. Negative 5/12 times negative 12/5. So negative 5/12 times its reciprocal. Since it's the same fraction just flipped upside down, everything's going to cancel or divide itself out. So we could say 5 times 12 is 60 divided by 12 times 5, which is 60, which is 1. Or we can think in terms of canceling. This 5 cancels with the 5 on the bottom. This 12 cancels with the 12 on the bottom. And negative times negative is a positive. So all of this also equals a 1. And lastly, 6 times 1/6 is really 6 over 1 times 1/6, which means everything cancels and it's just 1. So now let's look at why that's helpful to us. Let's see, we are going to move from multiplying fractions, which is what we did in the last lesson, to dividing fractions. So there's a saying that you need to know. It says when dividing fractions, do you see that I didn't finish it? When dividing fractions, don't ask why. Flip that second sucker and multiply. Y'all say, you read what I just wrote to yourselves for a minute. Okay, let's do it together. When dividing fractions, don't ask why. Flip that second sucker and multiply. What in the world does that mean? It means we're going to use the reciprocals that we just learned about. So we don't easily divide fractions. Instead, we change it to a multiplication problem where we multiply by the reciprocal. So we leave the first number alone, which is 7/12. But then we multiply by the reciprocal of 2/3, and it's 3/2. So 7/12 times 3/2 is the same as saying 7/12 divided by 2/3. And when we do the multiplication, we're going to have 7 times 3 is 21, and 12 times 2 is 22. And that is our final answer to that problem. So dividing fractions or multiplying by the second fraction's reciprocal produce the exact same answers. Let me look at something in my book really quickly. Yeah, this will help. Okay. Let's see. This is in the middle of the page on 126, and it'll just give you a quick example. So here we're going to look at a division problem. And you don't need to look at the first part, just this part. It says 2/15 divided by 2/5 equals 1/3. Now, how do we know that? Because we went straight across. 2 divided by 2 is 1. 15 divided by 5 is 3. But what if we do the same thing, but we multiply instead, and we say 2/15 times the reciprocal of 2/5, which is now going to be 5/2. Now we multiply. 2 times 5 is 10 on top. They don't have that written anywhere, so I'm going to write it. And 15 times 2 is 30 on the bottom. And 10/30 The greatest common factor would be 10, so if we divided both the top and the bottom by 10, it would reduce to 1/3. What they did instead was they wrote out the 2 times the 5 and the 15 times the 2, and then they canceled the 2's, and then they said this is just a 5 over a 15, which reduces to 1/3. So that's why it works, and it's often easier to do the multiplication because, as you can see here, we could not have easily said what 7 divided by 2 was. That was going to be a decimal number in our fraction. But if we flip that second sucker and multiply, we don't have to worry about that. So let's look at example B. Here we cannot work with this mixed number, so we're going to change it to an improper fraction. 3 times 4 is 12, plus 1 is 13, so 13/4. Now, remember, this whole number is really a fraction over 1, and we're going to, when dividing fractions, don't ask why, flip that second sucker, so instead of 4 over 1, it's 1 over 4, and multiply. Now do the math. 13/16, and that cannot be reduced. There's nothing that goes into both of those except for 1. Okay, this one is not dividing a fraction, but instead it's dividing a decimal. And the book wants to teach you a trick for doing that. One way that we could do the trick is the trick that we already know, which says this is 2.92 divided by 0.4, and all we do is move that decimal and make it there, and I'll make it big and bold to show where it really is. And since we moved that one once, we have to move this one once. And so we'll do it really bold there and really bold there. So we know that, oh, sorry, that wasn't helpful, was it? So we moved that decimal once, so we had to move that decimal once, and wherever it's really bold is where it's supposed to be. So now instead of saying 2.92 divided by 0.4, it says 29.2 divided by the whole number 4, which of course is easier. So what they tell you when you see a problem like this is look at the number that you're going to be dividing by. So that's going to be the number in your denominator. We could write this as 2.92 divided by 0.4. Whatever number that is that you're going to be dividing by, or is in your denominator, or is sitting right here, if you simply multiply it by a power of 10, that means a 10 or 100 or 1,000, you multiply it by whatever it takes to move the decimal to get a whole number in the bottom or in the outside of the division box. It's simply that that's the number that you're dividing by, and we want to make it a whole number. So we can do it by moving decimals, or we can do this, which is the same thing as moving decimals, and we can say, well, all we have to do is multiply it by a 10 to move that decimal one time, and 0.4 times 10 is now 4. You could do that on a calculator and see that that does work, or you could do it on your paper. And then, since whatever we did to the bottom, we must do to the top, so we multiply it by a 10, and that also means we move the decimal one place. And so now we have the same problem that we had up here when we just scooted those decimals around. So now we would simply do the math. 4 goes into 29 7 times, that's 28, bring down the 2, and that's 3. So the answer to number 2 equals 7.3. All right, just double checking my math. Okay, now let's look at this one. 7.2 divided by n, for n equals 2.4. So this problem is now going to say 7.2 divided by 0.24. Now we can notice, or we can do what they said. We can multiply this not just by a 10, but by 100, because that's what it's going to take to move the decimal twice. So times 100, and that's going to equal not 0.24 or 24 hundredths, but it's actually going to equal a whole 24. And then multiply this one by 100, and it's going to move the decimal place twice, and it's going to be 720. So now our problem's going to say 720 divided by 24. We could have just written this as the division problem and then moved our decimals just like this, like we've learned in the past. Either way would be fine, okay? Whichever you prefer. You might find that one to be easier, but it's just important to you that you understand the concept of what I was doing. So now we do the division here, and I am not going to take time to do that just for the sake of finishing the video. I know that you know how to do the division, so once you're done, that answer is going to be your final answer of what 7.2 divided by 0.24 equals. And we would do the same thing here, m divided by 3/8 for m equals 7.5. We would just plug in our m, which is 7.5, divided by 3.8. We will do this one all the way through. Can't work with that mixed number. Got to change it to an improper fraction. 7 times 2 is 14 plus 1 is 15 over 2. When dividing fractions, don't ask why. Flip that second sucker and multiply. Now, let's do our math. 15, 30, 45, 60, 75, 90, 105, 120 is going to be on the top, and 6 is going to be on the bottom. Now, I see this is going to be pretty easy to reduce because it really just works as a division problem. So 6 will go into 12 2 times with that 0 left over, and the answer is 20. Okay, so I wasn't going to show you this earlier because I didn't want to complicate things, but I am going to show you now so that you can avoid some of these big numbers. So we talked about cross-canceling. That's if we had something like 5 over 8 times 8 over 2 equals. Instead of multiplying that and that, we could have said, I recognize that an 8 on the top divided by an 8 on the bottom is just a 1 in both places, and my answer here is going to be 5/2, and I didn't have to reduce because I had already gotten rid of the things that made the numbers bigger. But I would then have to change this to a mixed number. 2 goes into 5, 2 times with 1/2 left over. Okay, so let's come back here and look at the next step of canceling. It doesn't always have to be the same number. It can just be numbers that go into each other. For example, there's not a 15 down here to cancel with this 15. But does a 3 go into 15? It does. So we can treat it like division on top of and bottom of a fraction. And it would say 15 divided by 3. 3 goes into 3 one time, but 3 goes into 15 5 times. And what about this one? Can we reduce this? This is just like reducing a fraction. Yes, 2 goes into both of these. It goes into itself once, and it goes into 8 4 times. Then I had a much easier math problem. 5 times 4 was 20. So just to make sure that you understand this, let's rewrite this problem. It was 15 over 2 times 8 over 3. But I'm going to write it as one fraction. 15 over 2 times 8 over 3. Now you see that these are really all in one fraction and that we can reduce, but only when we're multiplying. If we were adding or subtracting, we lose that ability to cancel because when we're adding or subtracting, it represents a number that's stuck together by that addition and subtraction. But when we're multiplying, we can take these numbers apart. So we can say that 8 divided by the 2, 8 divided by 2 is 4, and the 2 becomes a 1. Or you can say 2 is a common factor of both, so it goes into itself once and goes into 8 4 times. And we can say 15 divided by 3 is 1, and the 15 becomes a 5. 15 divided by 3 is 5, but canceling that 3 left it as a 1. Or we could have recognized that 3 was a common factor of 3 and 15, so it went into itself once and the other number 5 times. Works the same either way. Okay, let me see if we finished that. We did. Okay, so we're done, and you should be equipped to do homework on that, and I hope it goes well.